Well, howdy there, space cadets. Mr. Omniverse here, and today, we're going to fight the frickin' sun. That's right. The only thing in our solar system as hot as your sister. The sun's been strutting around like it's untouchable for the last 4.6 billion years, and it's time to take that ego down a few billion notches. Yes, I know what you're thinking. But Mr. Omniverse, doesn't the sun take up 99.86% of our solar system's mass? Well, yes. Yes, it does. But guess what? That remaining 0.14% has something that Gasp will never have. That's right. It's you. And I'm proud of you. So buckle up as we dive into the science of what makes this fireball so powerful, and how, with the right moves, you can bring it down. Oh, and please remember to like and subscribe for more cosmic adventures. Are you ready? Let's dive in. First up, let's take a look at what we're up against. I'm not gonna lie, the sun is big. It's 109 times wider than Earth and about 330,000 times more massive. It thinks it's hot stuff because its temperatures reach a toasty 15 million degrees Celsius in its core thanks to nuclear fusion. This fusion produces an insane amount of energy that powers everything from sunlight to solar flares. But it's no big deal. I've seen birthday candles that put on a more exciting show. And here's the real kicker. This precious fusion reaction, it relies on perfect conditions. Mess with that, and you've got yourself a collapsing star. So let's rain down on its cosmic parade and hit this wannabe gas giant where it really hurts. To take down the sun, we need to target its very heart, the core. Deep within, hydrogen atoms are colliding with such force that they fuse into helium, releasing energy that keeps the sun burning brightly and its ego eternally lit. But who cares about fusion anyway? We get it, Mr. Sun. You turn hydrogen into helium. That's basically cosmic finger painting. Bravo! A toddler could do it. So let's mess with the sun's stability by introducing a destabilizing wave of antimatter right into its core. Yep. The sun's about to get a cosmic dose of its worst nightmare. Picture this. The sun's core is happily fusing away, feeling all special, when suddenly, boom! Antimatter crashes the party and creates explosions of gamma radiation left and right. That'll end the sun's reign of terror once and for all. One by one, fusion reactions fail, and without those, the sun loses its ability to produce energy. You're a genius. And the sun? This so-called star of the show is left scrambling, trying to figure out how it just went from a blazing inferno to a cosmic dumpster fire. Oh no! What's wrong, Mr. Sun? Not feeling so hot anymore. Are ya? Now I'm sure you're wondering where to get enough antimatter to destroy the sun's core. Well, that's an easy one. Just harvest it from a black hole or even your local pulsar. But wait, we're not done humiliating the sun just yet, space cowboys. Now, as the core is destabilizing, the crybaby sun isn't just going to sit there quietly. Oh no, it's going to throw out some of its biggest temper tantrums and mood swings in the form of solar flares and prominences. These are massive ejections of plasma and radiation that erupt when the sun's magnetic fields get twisted out of shape. They can reach speeds up to 1 million miles per hour, and their power could fry entire planets. Yeah, we're not impressed. Cry harder, bright boy. With the core shutting down, these flares are like the sun's desperate cries for attention, a last-ditch effort to keep up its hotshot reputation. How pathetic. But here's where the fun part comes in. Each flare just weakens the sun further. The more energy it throws out, the more it drains itself, leaving it struggling to keep the lights on. And with the sun's core on the brink, let's focus on its outer layers, the photosphere and the corona. The photosphere is the sun's surface, the layer that shines in visible light, and above it is the corona, a superheated atmosphere that can reach 1,000,000 degrees Celsius, far hotter than the surface itself due to magnetic waves carrying energy outward. As the sun's core collapses, these layers start to peel off. The sun's magnetic field goes haywire, and the corona starts to unravel like a cosmic scarf caught in a windstorm. Plasma streams out, temperatures fluctuate wildly, and chunks of the photosphere start to flake away into space. The sun, once blazing and majestic, begins to look like a burnt-out, sputtering ball of gas. And you? Your sides are starting to hurt because you can't stop laughing. Imagine watching the once almighty sun go out with a fizzle rather than a bang. Feels good, right? And here it is, folks, the grand finale. With its core no longer able to sustain fusion, the sun starts to collapse under its own gravity. It's the ultimate irony. The sun, which kept the solar system in place, is now being swallowed by its own weight. The layers fall inward, temperatures spike one last time, and then it's bedtime for Bonzo. At this point, the sun is just a fraction of what it once was. It may end up as a white dwarf, a mere shadow of its former self. And you know what's hysterical? The sun doesn't even have enough mass to collapse into a neutron star or a black hole. It's just gonna sit there, cooling over billions of years, fading gradually into a black dwarf. A hypothetical end stage where it no longer emits significant heat or light. That's billions of years for it to reflect upon how crossing you was the biggest mistake it's ever made in its stupid solar life cycle. Congrats! You've just brought down a cosmic titan, stripped it of its power, and left it crying in cosmic dust. So there you have it. You cosmic legend, you've outsmarted, outlasted, and outright defeated the sun. What's next? Smash that like button, subscribe, and drop a comment on what cosmic heavyweight you want to face next. This is Mr. Omniverse, signing off, reminding you that in the end, you're the real star of this show. And remember, I'll always be watching you from the stars. Peace out.